Good morning, students. Today we are going to start the permutation. So what is permutation? Permutation is one kind of arrangement of some object which can be made by taking some or all of that objects at a time. For example, suppose there are three letters from English alphabet A, B and C, and we have to make some pairs taking two at a time. Then how many such pairs can we form? So let's break them into 2 by 2 form. So what are the options we will get? First we can form A, B. The first two we will take. So A, B, and then again we can take B, A, that will form another pair. So B, C, C, B, A, C, C, A. So in that way 6 such pairs we can form. So what will be the number of permutation of these three different letters taken two at a time? That is 6. Now let's discuss the notation of this permutation. If n and r are the two positive integers selected such that r is the greater than 1 and less than or equals to n, then the number of all permutations of n distinct things taken r at a time is denoted by the symbol npr, where n is written at the superscript of the p and r is written at the subscript of the p. So it is also can be written as p of n comma r. Thus npr means the total number of permutations of n distinct elements taken r at a time, and the value of this npr or p of n comma r is given by n factorial divided by n minus r factorial. That is, we have to calculate the factorials of n and n minus r separately, and we have to find the quotient. So this was the formula for finding the number of permutation of n distinct objects where r objects are taken at a time, but the repetition was not allowed there. In case the repetition is allowed, then the number of permutation of n different objects taken r at a time, but this time the repetition will be allowed, is n to the power r. Like we have seen in our earlier exercise, all the objects can be repeated for the next choice also. So n to the power r will be the number of total permutation there. Now let's know about some more theorems which will help us to solve the sums in this exercise. First theorem is the number of permutation of n objects taken all of them at a time is n factorial, because we can prove this one very easily, that here r is equals to the n. So npr, there we will put npn is equals to n factorial divided by n minus n factorial, and we know that 0 factorial, the value of 0 factorial is 1. So npn is equals to n factorial divided by 0 factorial, which is equals to n factorial only. So from there we are getting that the out of the n object, if we take all of them at a time, then total number of permutation is n factorial. Now the next theorem says the number of permutations of n objects where p objects are of same kind and rest all are different, then the number of permutation is n factorial divided by p factorial. Here also we will be taking all of them at a time. So n factorial should be the number when out of the n objects we have taken all at a time, and where p objects are of same kind, so we will divide them by p factorial. And similarly, if there exist more number of objects of another kind, they are also same, then we will be dividing that factorial also to n factorial. Now you do the sums from exercise 7.3 and let me know if there is any problem.
NPR, wonder what permutations are. The number of arrangements when order does matter, like in baseball games, the order of the us what permutations are.
So, in this beautiful song of permutation, the lyricist was repeating a line that order does matter. So, that is the main or basic difference between the permutation and combination. In case of permutation, the order does matters, but in case of combination, order doesn't matter. So, the definition of combination says that it is one kind of selection where out of the given n objects, the selection has been made by taking some or all of the objects taken at a time, but irrespective of their arrangements. That is the important, that the arrangement should not be considered as two different combinations. For example, if I have to select any two letters from the given three letters A, B and C, then I will be taking the selections as AB, BC and AC. But the opposite arrangements BA, CB and CA I will not be taking separately, because AB and BA, they are same in case of combination. The thing is, we have taken A and B together. Whether I have taken A at the first or B at the first, it doesn't matter. That is the meaning of order doesn't matter. Now, for the notation of combination, it is generally denoted by the NCR, that is the number of all combinations of n objects taken r at a time is generally denoted by NCR, where n is written at the superscript and r is written at the subscript. Also, it can be written as C of n comma r, and the value of this expression is given by NCR is equals to n factorial divided by the product of n minus r factorial and r factorial. That means the n factorial divided by n minus r factorial is itself the NPR. So, if I divide the NPR by r factorial, that will give us the NCR. So, from here we can get one relation between NPR and NCR, that NPR is equals to NCR into r factorial. Let's see some more properties of this combination. First property is, if the r is taken from 0 to n, and then NCR is equals to NC n minus r. And the proof is also very simple. If you apply the definition of NCR on both the side, you will get the right hand side is equals to the left hand side, so they are same. The next is NCR plus NCR minus 1 is equals to n plus 1 CR. And here is also the proof is simple. You can understand if you go through the proof part. Now you do the sums on combinations and let me know if there is any problem.
NCR, NCR, you wondered what combinations are. The number of selections when order doesn't matter. Foods for your plate from a restaurant.